Welcome back into the hangar. And the first question, did you enjoy lunch? Yep. I did as well. Algae, yeah. It's something you got to get used to. We know how healthy it is. As Rainbow was telling me, he was explaining, say, Chris, it's the real superfood. It's not the stuff you read about, but it's the real superfood. So I'm looking forward to learning to love it. How about Genius Loci? Who enjoyed the session? Yeah? Okay, who didn't put their hand up? I want to ask you what was wrong. That means you weren't at one, because they were pretty awesome, and they're repeated tomorrow. So if you haven't signed up yet, you can still do that upstairs for tomorrow. I think that's really exciting. Now, we ask you to think about what book is it, or what website that you think everyone should know about. And many of you shared that with us. Some of you did not. We encourage you, as you think over these days when you're here, what should a 2040 community library look like? Last year we asked the first group, as Rachel says, the zero group, to consider what books they thought everyone should know about and to bring. And this is the library which we started. And as this facility up here will be renovated in the next 3 years, there will be a library up here, which will be the 2040 library. So you'll be able to come back with your card and have it. But here are a series of books, ranging from The Hobbit, Circular the Donut Economics, Overstory, Will Gibson's Agency, Jane Austen, Pride and Prejudice, The Angriff der Algorithmen, The Attack of the Algorithm, Adam Grant, who cannot not read Adam Grant, Surviving the Century, Jean Prouvé, a couple of games from Brian. We're also up here, and you're welcome to come up here at any time and take a look. All right, this is not forbidden territory right here at all. This is just a convenient place so you can see it. So I would encourage you to come up, see how many of those you know, and what's not there. Now, we have a great dialogue continuing with the next three individuals who are coming up. One is again a local. I'm not sure how far Samaden is from here. I think about 100 kilometers or so, maybe. 50 kilometers, so you're even closer than Ernst, even more of a local. One from, I'm gonna have to look at Grenoble, who said, yeah, this is where all the nuts are from, and I'm nuts too. And then one from Amsterdam, who said, it's hard to get a flatter country than Amsterdam. So extreme diversity in location and where we are. So before I break them up, after this, we're going to go into some breakout groups, do a series of workshops this afternoon. We'll have one more dialogue before the day is over. And then we're going to go upstairs to dinner, same place where we were for lunch. And we'll have another conversation up there in the upper story where those who went to go upstairs into the bridge, that's where we're going to have dessert and our final dialogue, talking with those who had some projects from last year. What worked? What didn't work? Why did they work? Why did they not work? Because it's really important for us, for all of us, to really know what we can do to amplify, to act, to make things happen. So that's what's going to be happening tonight. It is a long day. You know that? But that's the arc. I'm telling you this so you can think about your energy and the amount of coffee you're going to grab. Or the sugar, if you're telling you to pick your poison. Any questions? Looking at the team, okay? All right. So, we call water a magical molecule. I'm just fascinated by it. I didn't know I would be as fascinated with water as I would be. Composed of two small, positively charged hydrogen atoms and one relatively large, negatively charged oxygen atom. It is how we, in many ways, define life. When we're looking for life outside of our planet, our solar system, our astrophysicists or astrobiologists are looking for signs of H2O. This is what they look for when they're looking for other planets. And every single living thing that we understand on our planet depends on water. And yet, a lot of that water is locked up in ice, in glaciers, it's locked up in groundwater, it's locked up in political boundaries. And just this year, science has a new definition of fresh water, which includes both blue and green, which is kind of really cool. Antarctica holds approximately 60% of all the global fresh water, and it's a hotbed for research and houses what we like to call our global ice memory. And then the question when mountainous regions who depend upon, as Reto was describing earlier, their glaciers and glacier melt for their very existence, the question is, how can we help those water reserves last longer or create new ones with stupas, which is a very natural, ancient form of water. So for us, it was trying to also understand this critical role that ice plays in the provision of a stable climate, dig into the governance and opportunities for green water, and also talk a little bit about how the UN governs that large reserve. So, without any further ado, I would love to invite up to stage Felix, Sophie, and Jerome. Come on up. There we go. And it's a fantastic crew we have here. Felix is from Samaden, a glaciologist, a resident local, as Rachel likes to say, an indigenous, an aborigine. He works on a project to slow down melting processes of glaciers, developing a technology called the snow cable, which we're going to hear a little bit more about, which can produce about 5,000 tons of snow without electrical energy. And if successful, can truly slow the disappearance of our glaciers. Sophie from Amsterdam. She was one of the co-authors of this redefinition of the blue and green water and the planetary boundaries and understanding green water governance, which was very intriguing to me. I think this is quite exciting for us to hear about this new boundary, what it is. And Jerome uses natural ice as a recorder of history, recognizing that in one day, scientists will have lots of new techniques which we don't understand yet, and if we don't save the ice we have, it will truly be gone forever. And who knows how much microplastic will be in it at that point. All right, so I want to ask the first question for each one of you, and we start with Jerome at the very, that's your passion. Explain a little bit more about ice memory and why.
Well, first of all, ice is a fantastic material for us scientists, not only because it's water and it matters for the world, but it's a memory of the planet. Anytime you have a snowfall at the surface of the glacier, the snowfall is made of water, of course, but it's made as well of a lot of tiny particles or chemicals which are present in the atmosphere, and that will be incorporated in the snowflake. So when the snow gets denser and becomes ice, in the layers of the glacier, we find the composition of the atmosphere through time. So the job of our activity, so-called ice core scientists, is to go on specific glaciers that are interesting for their regional representativity, and we collect a cylinder of ice, about 10 centimeters of diameter, going from the surface down to bedrock, and it's like a book. So we go page by page through the history of the planet. And it's a science still quite young. It was born about 70 years ago.
17 or 70?
70 years ago. And we can already see the evolution of this science over 70 years. What we could learn from the ice core 70 years ago and what we can learn today is quite a fantastic evolution. And our bet, in a way, is that in the future there will be new technologies, there will be new ideas in bright minds, but there will not be anymore the raw material, because as you all know, glaciers disappear. And it's the case in basically all mountain areas. It's not yet the case in Antarctica, not yet the case in Greenland, but in the Andes, in the Alps, in the Himalayas, we just lose this raw material. So ice memory is about collecting ice cores that we will put in Antarctica, which is the best freezer on the planet. It's still very cold, and it will remain cold for a few centuries to millennia. And we will keep these ice cores there for the future generations of scientists.
So this is sort of the same way as we have the seed vault.
Yeah, except that it is not going to be our property. The seed vault, there is still a question of property there. Those contributing the seeds are still owner of the seeds. In our case, we think it has to be a universal legacy.
Interesting.
So the ice core really has to be available for the whole scientific community in the future.
Yeah, that's very cool. And Sophie, what are planetary boundaries? Because we use this as something that's important for us. How many of you know what the planetary boundaries are? How many of you are not really sure what they are? How many could quote all of them? Oh gosh, you geeks. Okay. All right. So tell what are the planetary boundaries, and why should we care?
Yeah, so I actually saw that they're part of our objective, right? To accelerate the transition to a planetary boundary compatible society. So it seems like they're quite fundamental to what we're thinking about. So the planetary boundary framework was a scientific framework that was developed in 2009. And it has inspired a lot of policymakers and also new concepts on how to deal in a society with boundaries, and also other frameworks. So Kate Raworth's donut economy is very much based on a planetary boundary framework. But what it basically says is that in the past 11,000 years, the Earth system as we knew it was very stable. And this has been the period where human societies have evolved and flourished. And so this is the system that we know. And, but it's a very complex Earth system. And the planetary boundary framework says there are 9 elements that actually define this Earth system as we know it. And it says that as humans, we should not intervene in these systems to a certain extent, because if we do, we risk that we actually moving away from the stable Holocene conditions. That was the period of the interglacial that we've been living in the past 11,000 years, and we are risking actually a change of the Earth system as a whole. So,
and you've been working on, so as Rockstrom says, these are the guardrails within which humanity needs to sort of move.
Exactly.
Right?
It's called the safe operating space for humanity,
right.
And it basically says that we have a certain degree to which we can intervene with the Earth system, but if we cross those boundaries, we're at risk. So the ecosystem itself is at risk as at the planetary scale, but also human societies are at risk.
Yeah. Now, and you've defined within freshwater, you've helped redefine our thinking about freshwater.
Yes.
Explain that a little bit more in more detail for us.
So initially the freshwater planetary boundary was defined as extractive blue water use. So that's the water that humans actually extract for agriculture, for industries, but also for direct use as drinking water. And they extract that from the river systems and lake systems, etc. So that was basically the way in which the framework defined human interaction with the water system. Back then already it was said that this was a bit of there were already some critical thoughts about this was not really the way, the water cycle functions as a cycle, and only looking at water extraction from a river system is not actually representative for the ways in which humans use water and also change the water system. So we call blue water the water that we can see, which is liquid, which goes through streams, is captured in lakes, but also is captured deep down in the earth in aquifers. And we added a component to this planetary boundary framework which focuses on green water. And green water is the water that we can actually not see because it's captured in soils, but it actually comprises a large part of the available fresh water on the Earth's surface. And it's not actually taken into account when you only look at the extraction of water, but humans change the water in the soil to a large extent due to land use changes, agriculture, deforestation, etc., and really intervening into that green water system.
And so I think it's really interesting that they say the blue is what we can see on the surface, and the green is what we don't see, which is entrapped and held inside. It's not the green water we see because of the glacier flower.
No, it's like
That's right.
it's not
right?
green in its color.
Right.
There's categories, and also we sort of categorized water in different colors to make it understandable. There's also white water, which is then the glaciers and stuff.
Yeah.
But it's not actually green. It just says something about where it is located.
Because here in the mountain we do love our green water because, and it's because of the algae that might be in it, which I grew up with in Ohio, where it was green for a whole different reason. Thank you for that. And Felix, tell us a little bit more about when I start off with the project on the Morteratsch, and what are you doing there and why?
Yes, so for me it was surprising because always I had to connect blue and green water, and I observed that all our glaciers are melting, worldwide phenomena. And then I realized that using the blankets which are used in the ski resorts, I heard from an example at the Diavolezza ski area in the Engadin Valley, where they were able to produce a positive mass balance by snow farming. And this was surprising for me, because I didn't believe it first. And then I was asked from my CEO, from the Academia Engadina, that if I would be a good glaciologist, it should be possible to slow down the melting process also of the glaciers. And first I thought, this is impossible, because it's a question of the dimension. But then his answer was, yes, but he believes that I'm one of the scientists which likes much more to describe a lot of problems, to publish all the problems, but we have no solutions. And for me, this was not so very comfortable to be in this position, but I felt that I'm right, that this is not possible to slow down the melting processes. But the next day, by fishing, I thought, but however, from the theoretical point of view, maybe it could, however, work. And then I had a very simple idea. I will call this idea meltwater recycle. The question was simple. What would happen if we would collect the meltwater, which occurs in summertime? We would store it in the high elevated region, and then in the next winter time, when it is cold enough, we could produce snow, and snow is a very good material to protect the glacier from melting. And so this is a kind of meltwater recycling. First, I thought it is very easy, and in fact, the idea is quite simple. But to take action is something a little bit other, because then we realized for the Morteratsch glacier that we need a system which is able to produce snow with an amount of 30,000 tons of snow a day without electrical energy. This is the question.
30,000 tons per day.
Per day, yes.
Easy.
Very easy, yes.
Yeah, easy. Come on, yeah.
I calculated that we need about 300 snow guns to put on the glacier, but the glacier is moving and we have no electrical energy. But then, first I thought, this will never work. But then a colleague from me said, yes, but you are one of the scientists which only knows the problems. do you not have a vision? And then the vision was, we are here on a cable car station. If we would try to combine cable car technology and snow-producing technology, this could work. And now we are on this project. Last winter, the first installation was working in the Diavolezza area, and now it would be ready for the next winter if a ski resort would be ready to install such a snow cable, which is not using energy, electrical energy. We use energy, water power is water pressure. This is also a form of energy, but not an electrical form of energy. Then we would be a step forward, and this also then started the connection with the people from Ladakh. You mentioned already ice stupas, because they are already saving fresh water in frozen forms. And so I learned that take action is much more important than to describe problems.
Yeah, that's great. And I think, Jerome, the two of you share a stupa fascination.
Kind of, but I don't think what the repository we will create in Antarctica will have the shape of a stupa. It may be a bit difficult. We will probably produce something else.
But so the idea of the stupa, how many of you know what a stupa is? So that's quite a few. It's more than I expected. So it's essentially, you have a pipe, or some place that's just spraying water, and it freezes as it comes down and creates this massive cone, a mountain of ice.
Yes, mountain of ice, the stupa can be reached about 40 meters high.
About 40 meters high.
40 meters, also like a small church of ice, a wonderful form of ice.
Yeah, that's fantastic. And then the idea is that it melts and provides water to the villages.
Exactly.
That's right. So how far are we with this idea of providing water to these mountain villages in different parts of the world? You both are, this is something you all are thinking about in different ways. Where are we with this, with the technology, you said it's already happening. Someone tell me where we are. We have hope with this? It's acting?
I think it's a form of acting, but it is only adaptation. Also, I think the need for climate protection is given as well. This is no question. But it's a form, I didn't know that more than 200 million of people which are living in arid mountain areas are highly dependent from the melting water from the glaciers.
So I want to change tack to another question, and it is Antarctica. Antarctica is a continent which has a unique governance structure, if I'm not mistaken. Something which is a potential exemplar for what we need to be thinking about when we're looking at climate change.
Yes, it's a so-called Antarctic Treaty. It's quite a unique tool for a governance of part of the planet. It was created in 1959. It was the Cold War. But it was just a follow-up of the so-called International Geophysical Year, when 12 nations decided to work together to better understand the planet. And I think it was really the first key action, international action, to work on the planet. And then it was decided by the Soviet Union and the USA to kind of protect this area. So that makes that 7% of the surface of the planet, that is everything south from the 60 degrees south parallel, is protected by this treaty. So it makes that it does not belong to anybody. There are countries which have claims on Antarctica, but these claims are said to be frozen. That means other countries can say, no, it's not your belonging. And it made that this area is only for peaceful activities. There should be no nuclear activities there. And then in 1991, a protocol was adopted in addition to the treaty, making that Antarctica became a natural reserve dedicated to peace and to science. So it's quite a unique format. But I had the chance to be part of these delegations where we meet once a year, 54 nations, discussing about what we should do with Antarctica. And the principle is consensus. And I would say until recently the consensus could be obtained, and now it becomes more and more difficult because some countries, you can expect which ones, use Antarctica as a place to say, we count on this planet. Our voice is important, and maybe more important than the voice of others. So I don't know how long this system will last. It's hopeful, but at the same time, we can see on the way it works now, it becomes more and more difficult.
So Sophie, I see you kind of nodding your head to this issue with governance, consensus. Tell us a little bit why you're nodding your head here.
It's, so when you look at water governance as a field, which I now define as the rules and regulations and institutes that we evolved around the resource, so they explain how do we deal with something. And this negotiation process, of course, I was nodding because you said some countries are now making these negotiations more hard, basically, if it's dealt on the principle of consensus. So if you look at water governance, it goes back to more than 5,000 years in which rules and regulations have emerged from human societies making rules about water. So most of those rules were grounded in religion. So religion telling how you can use and access water, to what extent. But those rules and regulations have really emphasized blue water resources, and that's it makes sense to a certain extent, because in a large part of the world we still don't have a proper water system in order, right? Still so many people are having a lack of access to clean and affordable water. So the emphasis on blue water is sensible, but it may need to expand to also include other water forms such as green water and white water. Yeah.
So when you hear, wait, Felix, glaciers. So green water goes through many different jurisdictions potentially, or is green water very local? Or glaciers can be very local. Antarctic, as we've just heard, is sort of global.
Like global.
So it's sort of this hierarchy of scales and localities. So with glaciers, it's easier because you're talking to one state, one country, except we have a border glacier. Is that, I'm assuming this is correct. Am I, yes or no?
Yes.
Okay. So when we're looking at green water, is there new challenges or some new actions with green water regulation that we could be aware of or should be aware of? Or can you give us an example of something which is working or exciting or excited about when it comes to this exact issue?
Yeah, so there is not much regulation in place as of now that specifically targets green water. But what we are understanding more and more is that, so when we look at water systems through rivers, we have dealt with river systems as a transboundary system. So there are over 900 transboundary agreements in the world in which countries have agreed on certain rules with respect to how to deal with this river to ensure that the water remains a certain quality, that everyone can access a certain amount of water. For green water, not so much, but we're now seeing that soil moisture and evaporation from the land surface, particularly through dense tropical forests such as the Amazon, are really, we talk about water towers, right, as is the mountain areas, but these forests are also sort of water towers in the way that they evaporate large amounts of water, they transport that water back or further into the continent where it then rains out. So what you see is that the Amazon forest actually provides a lot of water resources over the South American continent that is also crossing national borders.
Yeah.
So we have to see that as a system that is not only local, but is actually cross-continental.
Fascinating. So who has a question right now? Someone have a question they'd like to ask of our three up front? Anyone have a question burning? Brian has one up front. Who else has a question? Anyone else have? And then Tobias has a question. So let's come up here, right here. Brian, and the other one can go to Tobias.
My question,
What number you have?
number 7, yeah.
Yes.
My question is, I'm a little bit confused about the boundary between blue water and green water, because effectively I see green water, given human intervention in large-scale intensive agriculture, seems to me that green water comes directly out of blue water and is sort of a subsidiary concept. Am I wrong, or can you explain that better? The second point I want to make before you answer is that I have a personal stake in this discussion because one of my ancestors back in western Colorado was actually hanged for stealing water. He was lynched by his neighbors for diverting a stream up in the mountains. So
Really?
just a comment.
So, what's your view on lynching? For water, no.
So,
yeah.
shall I respond
Yeah,
now?
please.
or
Yeah,
first?
that's really interesting, actually.
So the water that's captured in the soil is both in a liquid and gaseous form. But most importantly, the distinction comes from, if you look at the hydrological cycle and maybe pictures you've seen back in school or in studies, you see this mountain where you have rain and snow, and then you have a stream, and then it goes to the ocean where it evaporates, and then it's transported back over land and then precipitates, right? So this is the hydrological cycle as we think we know it. But then if you look at it, the half of the rainfall that falls on the terrestrial surface doesn't go through these streams to the earth, to the ocean. It actually evaporates back to the atmosphere from the land surface. And then, of course, in the atmospheric domain, it can also reprecipitate back on the Earth's surface, etc., or be transported wherever. So it's the difference is that the water that's the blue water that's in the stream is only a small part of the water that actually participates on the Earth's surface.
So what about aquifers? Is that blue or green?
That's blue. Yeah,
Okay.
that's you could argue that it's a sort of
It's a blue-green.
sort of in the middle. Yeah,
So
it's
blue-green.
turquoise.
Yeah, yeah.
Turquoise.
It's turquoise. Yes, it's turquoise. It's turquoise water. We have white water, turquoise water, blue water, green water. Okay, good. Okay, Tobias, you had a question.
Yeah, number 8.
Number 8. Go ahead.
Yeah, my question is regarding the interesting glacier project. And so just thinking of it practically without understanding maybe everything of it, but you would take much or some of the runoff water, capture it,
Yes.
bring it up the mountain again, so it would not be readily available for downstream use of water.
Yeah.
So one thing about the question, what that mass or that water balance would mean to downstream ecosystems. And the other question, when you bring it up, maybe I misunderstood, but to bring it up, you have to pump it up, or is there a way by gravity bring it up?
No, we haven't to bring it up because it's so warm, we can just use the meltwater which occurs in the higher elevated region and produce the snow in the region which are lower.
I see. And so would it be possible if the water pressure by gravity is high enough to actually produce through, these fine jets of water vapor that would lead to snow at the end? So does it have to be that ice cone
Yes.
that described, or can it be in the right time of the season a real kind of snow where you don't have to pump the pressure, but it comes by the pressure of the gravity?
Yes, as we use the pressure from the gravity, we need 20 bars. And so we are able to produce with these 20 bars the air pressure and water pressure which is needed to produce the ice cones.
And so
then,
I just want to make sure so it's clear. He has actually created a cable which sprays a mist. So it's not just a stupa, but it's just like a snow cannon.
Yeah.
It's similar types of nozzles which spray out the water.
And then to the other question which you asked, because concerning when we use the meltwater, from warm days like it was yesterday, we estimate that the Morteratsch glacier, the glacier from which I know a little bit, the Morteratsch glacier loses in one day, in a hot day, about 1 million tons of ice in one day. And to do this project, we need for the whole year 2 million tons of water. And so the amount of water which we capture in the high region is so small that it doesn't affect the ecosystem. The ecologists, they say us it would be better if there would be less meltwater, because it's too much meltwater actually in the rivers.
Great question, thank you.
To give you numbers, if I can, about the Ice Memory Project, and it's related with what Felix said. We're going to Kilimanjaro in September, and Kilimanjaro Glacier, the remain is only 50 meters of ice, and the Tanzanian authorities worried about how much ice we would take over. And what we plan to sample is what the Kilimanjaro Glacier loses every 2 minutes. Naturally, kind of. Yeah.
Wow. It's a whole different scale.
Yeah.
Truly, in every sense of the word. I'm going to ask you one last question. Jerome, I got a question. When you've been looking at these ice cores for a while, what has surprised you?
I think the surprise is that when you look at the ice, it's transparent, it's inert, and there is a hidden story inside that you cannot see. So the work is to understand it and to read the alphabet. It's a natural alphabet, and we don't really know the letters. So I find that fascinating, that nature could kind of write a book with a special alphabet, and it's kind of a game for us to try to understand it. That's the story of the planet.
Yeah. That's a beautiful, I think actually that's a beautiful way to stop. Truly, that's really very poetic, very beautiful, and thank you, especially, you're saying that there's so many mysteries we don't understand yet. And the more we learn, the less we know. But we know we have to do some things. And that's the key. Thank all three of you very, very much for your passion and dedication. And I look forward to learning more from all of you. So thank you so much. Thank you.